There's only one way to see the stars while the sun is out, and that's during a total solar eclipse. You have to be at the right place at the right time, under a clear sky, standing somewhere along the narrow path where the moon aligns perfectly between the sun and the earth. When the moon passes in front of the sun's disk, it darkens the sky just enough for distant stars to become visible. There have been many photos of total solar eclipses, but this one is special. It helped prove a radical idea that redefined gravity and turned Albert Einstein into a celebrity. Because the stars in this photo aren't where they're supposed to be. Isaac Newton laid the foundation for understanding the physical universe in the Principia, published in 1687. In it, he defined gravity as a force of attraction that draws massive objects, like stars and planets, toward each other and keeps them in orbit. And for more than 200 years, gravity was defined this way, as an attracting force. But Albert Einstein saw gravity as something completely different. According to his theory of general relativity, which he published in 1915, gravity isn't a force between objects in space. It's the influence of objects on the shape of space itself. According to Einstein, massive objects like the sun bend the space around them. So when a smaller object moves in a straight line along this space, it gets diverted because of the curve caused by the mass of the larger object. That puts one object in orbit around the other. And if Einstein was right, then the same curve would divert the path of light as well. Meaning, if you observe distant stars through a telescope on Earth while the sun is in front of them, their light, deflected by the sun's gravity, would make them appear slightly out of position. It was a revolutionary idea, but there was a big conflict keeping Einstein from testing it. The world was at war. Einstein lived in Germany at the time, but his work landed in the hands of a British astrophysicist, Arthur Eddington. Even though they were on opposing sides of the war, Eddington, along with astronomer Frank Dyson, set out to test the theory. They would photograph a total solar eclipse. They needed to compare the position of a cluster of stars in the night sky with a photograph of the same stars during an eclipse. If the stars' apparent positions had shifted, it would prove that starlight was traveling through space curved by the sun's gravity. The May 1919 eclipse was the ideal one for this experiment. The sun would be in front of a very dense cluster of stars, the Hyades, and that meant multiple bright stars would be visible during the eclipse. Planning began in 1917, and a couple of years later, 2 expeditions departed England. One, led by Eddington, went to the island of Principe in West Africa, and the other headed to Sobral, Brazil. 2 locations that were in the path of the eclipse and had favorable climates. Each group traveled with powerful photographic telescopes that could record detailed photos of space onto glass plates. Photographing the eclipse that May required transporting and then carefully assembling them in the field, with the plates tilted 45 degrees on one of the telescopes to include as many bright stars as possible. And this was the result. This is one of the few successful plates from the 1919 expeditions. It came from Brazil. It shows the eclipse during totality, the sun's corona bursting forth, and the rarely seen solar prominence. Most importantly, bright stars of the Hyades. Back in England, Eddington compared the position of the stars from the eclipse plate with another of the night sky, using a machine that can take measurements within photos at the microscopic level. The comparison revealed that the stars had shifted during the eclipse by roughly the amount that Einstein predicted. According to Newton's calculations, starlight should bend near the sun too, but if Einstein was right, that deviation would be twice what Newton predicted. Eddington's result showed that the deflection of the stars came closer to Einstein's calculation than Newton's. It wasn't a perfect match, but it was close enough to validate the theory of general relativity and completely shift our understanding of the universe. The success of the experiment was first announced in the Times of London on November 7, 1919, almost a year to the day after the end of World War I. An Englishman had gone to great lengths to prove the ideas of a German, and the news that space is warped by the planets and stars excited the world. Einstein, who before this moment was only known in the physics world, essentially became a celebrity overnight. He remained an international pop culture icon for the rest of his life, and a favorite subject of press photographers. Observing eclipses continued to be one way of testing general relativity for decades to come. with more sophisticated equipment repeatedly confirming the accuracy of Einstein's theory. General relativity allowed physicists to begin to understand advanced concepts about the universe, like black holes, which ultimately led to this, the first photograph of a black hole, taken in 2019, a century after Eddington first proved Einstein's theory with a photo, and completely changed our definition of gravity.